In this unit, we are going to focus on multiplying whole numbers. Now, you will notice in every unit that has anything to do with operations in 5th grade, we will have our estimation teak. And the reason we do that is we want every conversation to start with a discussion of a reasonable answer. Reasonable answer. So that way we know before we ever start solving what is a ballpark, what are we expecting our answer to be close to, so that we can discuss when our answer doesn't make sense or not. If we just look at kids and say, that doesn't make any sense, that answer can't possibly be right, they don't know that. They don't know that it doesn't make sense unless we've had a conversation with them about what would make sense. And estimation is the vehicle for that. So we start every problem with an estimated answer of what would make sense for our answer before we ever start the actual solving of the problem. Now, like our previous unit with adding and subtracting whole numbers and decimals, every problem is going to be a word problem. So we're not going to present kids with problems that are just out of context. There needs to be a context so they understand why they're multiplying. So we're talking about problems in a word problem, a real world setting, so that we're able to make connections to why we're even multiplying to start with. Now, this is a supporting standard in this unit because it builds to 5.3e, which is our solving for products of decimals. So in 5th grade, 5.3b, our multiplying whole numbers, is supporting that decimal unit. Well, then why do we do it separate? Well, we do it separate because the requirements of this standard grow from 4th grade to 5th grade. In 5th grade, students are required to multiply up to a 3-digit number by a 2-digit number. They didn't have to do that in 4th grade. They did a 4 by 1, a 3 by 1, a 2 by 2, but they did not do a 3 by 2. So we are going to look at a couple of different ways that you will see kids solve these problems because I want you to be familiar with them. Though your standard says solve with the standard algorithm, we are not going to say to students you can't use another strategy that you've learned and that you're comfortable with because I want to force you to pick my strategy. So we are going to teach the standard algorithm. Our goal is to move students to the standard algorithm, but if a student wants to use an array or an area model, or they want to use partial products while they're learning this, that's great as long as they have a strategy and we're working them toward the standard algorithm. Remember, we're introducing this now in Unit 3 of the year, but we're not expecting mastery today. So if they are moving toward mastery, which would be a 3 by 2 using the standard algorithm, then we're golden. We're not going to say to them by the end of this unit in however many days you have, 9 days I think, that you have to be mastering the standard algorithm. We want them working toward that. So there are strategies that you may see your students using. You may see an area model, and I'm going to model each of these for you. You may see partial products. And then you may see the standard algorithm because they have learned in prior years the standard algorithm. So in 4th grade, they learned each of these. Now, it's so important that we are working toward the standard algorithm because by the time we get to multiplying and dividing decimals, if students are still relying on these strategies, it does make it considerably harder with decimals. It is not impossible, but it is definitely not an efficient way to solve when you're multiplying with decimals. So remember, our goal is to move them toward the standard algorithm so that we are working toward a more efficient model. So I'm going to use the problem 325 times 12 to model each of these strategies. So I'm going to start with an area model. And I want you to see how each of these connects as we go through this progression. So if I was going to solve 325 times 12 with an area model you may have heard called the box method or a window pane, we break the two numbers apart by their place value. So this would be 300 plus 20 plus 5, and this would be 10 plus 2. And then we are multiplying 300 times 10. So it helps kids, you may see them write like this in the box. They learned to do this in 3rd grade. Kids should be graduated past needing to write this out, but if they're not, that's what they're writing. 300 times 10 is 3,000. 20 times 10 is 200. 5 times 10 is 50. Then we would do 300 times 2 is 600. 20 times 2 is 40. 5 times 2 is 10. Then we would need to add these together. So we would have 3,000, and sometimes it helps. You'll see kids do, in this case we don't have any ones because it's a 10. Hundreds, we would need to add 600 and 200. Tens, we would add 50 and 40 and 10, and there's not any ones. So we would have 3,000 plus 800 plus 100 equals 3,900. So that's the area model. Then you see kids move toward partial products, and there are varying levels of partial products. There are varying levels of how kids may be breaking the numbers apart for partial products. It's going to depend on their proficiency level. So you may see them thinking about these numbers very similar to the way they did in this. They may write, so here's my problem, 325 times 12. They may write 300 times 10, 20 times 10, 5 times 10, and then they would write 300 times 2, 20 times 2, and 5 times 2. And then they would solve these. 3,000, 200, 50, 600, 40, and 10. And then add them all up. Now, they may, as they get more efficient with this, say 300 times 12, 20 times 12, 5 times 12. Or they may say 325 times 10, 325 times 2. So they're taking they're taking their numbers apart and finding a partial product. And so then as they move toward the standard algorithm, they're able to start making some of those connections. I like to see kids get to the point that they're doing, I just wrote the number backwards, 325 times this. Because when you solve with the standard algorithm, it's a beautiful connection. It's perfect. And they're able to see why their answer is what it is. So 325 times 12 they're able to see, oh look, this is the exact same thing as this partial product that I did here. So they're able to make that connection. Now there's a really, really important thing that I want to discuss, and it's this 0 right here. Please teach kids why there's a 0 there. Please don't teach them a silly little rhyme or a smiley face or an X. There's a 0 there because we're multiplying by 10. We're multiplying by 10. And anything I multiply times 10 has a 0 at the end. So 325 times 10 is 3,250. I'm not multiplying by 1, so please don't say, okay, next we're going to multiply by the 1. We're going to multiply by a value of 10. And when I multiply by 10, or any multiple of 10, what goes in the 1's place? A 0. Then I'm able to multiply. So please don't teach tricks for remembering a 0. Teach them the place value. This is 10. If it was 52, I would be multiplying by 50, which is a multiple of 10. And what happens when I multiply by a multiple of 10? It ends in a 0. So there's a 0 here. So please make sure you're teaching the math behind that, not a trick for it.